Welcome to this explainer. Today, we're unpacking a massive paradigm shift happening right at the intersection of digital transformation and environmental sustainability. For the longest time, these were treated as completely separate operational tracks. But today, they're converging into this unified strategic imperative. We are literally looking at a fundamental rewiring of how global enterprises and municipalities operate. Which brings us to a really fascinating question. Does technology naturally drive sustainability, or does sustainability actually drive technology? People usually just assume digital tech naturally improves ESG. That's environmental, social, and governance outcomes, by the way. But empirical research reveals a totally counterintuitive reality. High ESG performance actually buys the resources needed for advanced digital upgrades. It's a two-way street that's completely reshaping corporate value creation. To really wrap our heads around this unified imperative, we're going to map out 6 distinct pillars of responsible technology. 1. ESG drives digital transformation. 2. Connecting smart city infrastructure. 3. Greening our core industries. 4. The global e-waste crisis. 5. Creating circular IT ecosystems. And 6. Return on sustainable IT. All right, kicking things off with Section 1, ESG drives digital transformation. Let's look at how the old silos of tech and ESG have just completely dissolved. So let's dive right into this idea of reverse causality, because it totally flips the traditional narrative on its head. Superior ESG performance acts as a massive green flag for the market. It reduces investor hesitation and actively attracts preferential investments. We're talking capital markets, government subsidies, special green loans, the whole shebang. Basically, hitting those high ESG marks alleviates capital constraints, unlocking the funding you need to pay for high-cost, high-risk digital infrastructure and next-generation software. And let's see how this builds internally, because this reverse causality isn't just about the money. Aligning with rigorous environmental guidelines actually trains an enterprise to sense external changes and rapidly reconfigure its internal structures. Your adaptive capabilities grow as you shift to flexible cloud architectures to meet changing guidelines. Your absorptive capabilities strengthen because, rigorous ESG reporting demands robust big data analytics. And your innovation capabilities, they absolutely skyrocket because designing products with a low environmental footprint inherently fuels technological risk-taking. It really helps to think of ESG and technology as a continuous, mutually reinforcing loop. Digital technologies are like the roots necessary to measure, track, and report environmental impacts, while ESG mandates form the branches that dictate the very design, procurement, and lifecycle management of enterprise technology. They constantly feed each other. Moving right along to Section 2, connecting smart city infrastructure. Stepping out of corporate strategy and into the physical world, let's explore how our municipalities are digitizing to meet crucial sustainability goals, like the UN's SDG 11 and 13. The physical infrastructure of modern societies absolutely must be digitally connected to remain sustainable. And honestly, the sheer scale of these projects is awe-inspiring. Whether we're looking at a massive forest-themed plotted development at the Delara Forest Estate, or sprawling cloud-based IoT suites like Siemens Smart Infrastructure, these spaces rely heavily on real-time data collection. You absolutely need advanced sensor systems to enable real-time resource optimization across entire urban grids. Just look at how these specialized sensor networks operate in the real world. Smart buildings track temperature and occupancy to save power. Smart utilities use ultrasonic sensors to prevent water and gas waste. Public safety grids rely on early hazard warnings. And parking management uses distance sensors to guide drivers, which directly reduces urban traffic emissions. By building scalable data environments with advanced sensing systems, governments are successfully transitioning from reactive administration to predictive, highly eco-friendly resource management. That brings us to Section 3, greening our core industries. Now, what's really fascinating here is how these macro-level IoT concepts are taken and customized for specific, heavy-hitting industrial sectors. Vertical-specific demand is completely transforming these core industries. For instance, in healthcare, advanced diagnostic networks are powering eco-friendly hospitals that target zero-waste medical processes. In travel and tourism, AI-powered route optimization is heavily minimizing fossil fuel use and fleet costs. And in Industry 4.0 and manufacturing, digital twins and departmental automation are not only promoting sustainable material tracking, but they are lowering factory IT spend by up to 40% compared to legacy on-premise solutions. Digital integration is driving both climate action and operational agility at the exact same time. All right, time for Section 4, the global e-waste crisis. As enthusiastic as we are about these advancements, we really have to pivot to the dark side of tech growth, the staggering environmental cost of our digital appetite. 50 million metric tons. Just think about that drawer of tangled, obsolete chargers and old phones you probably have sitting in your house right now. Globally, our reliance on a linear hardware model has made e-waste the fastest growing waste stream in the world, generating a staggering 50 million metric tons of toxic electronic waste every single year. And it gets even more pressing. If we just continue business as usual, empirical projections show that within the next decade, the upstream extraction of raw materials, manufacturing, and transport of digital devices is going to account for nearly a quarter of all global carbon emissions. Let that sink in for a second. 25%. Just from the technology sector alone. So how do we fix this? Section 5, creating circular IT ecosystems. To decouple explosive digital growth from total resource depletion, we must fundamentally change our relationship with hardware. We have to absolutely abandon the linear fallacy of take, make, use, and dispose. Instead, the focus has to shift to a circular ecosystem: collect, refurbish, reuse, and recycle. The basic premise here is to design out waste and keep components and raw materials in use at their highest possible value for as long as possible, before finally regenerating those natural systems at the very end of the hardware's life. Sustainable device management relies on 4 dimensions of green computing, which form a strict hierarchy. First up, green use, maximizing the energy efficiency of the active operations we already have. Then, green disposal, through responsible e-waste recycling. Moving up the chain, we have green design, actually engineering non-toxic hardware and software right from the start. And finally, green manufacturing, which minimizes water use, resource consumption, and emissions during production. And hey, this isn't just some theoretical concept. It's happening globally right now through structured IT asset disposition, or ITED programs. For example, Greentech Riemann in India is doing incredible large-scale copper and gold extraction. Over in North America, the ERA refurbishes technology to bridge the digital divide. Down in Oceania, ITED NZ focuses on secure data destruction and leasing, while in Europe, the Circular IT Group is rapidly scaling device-as-a-service models. And in Africa, Colm Solutions is running community buyback programs. Across the globe, these structured frameworks are enabling enterprises to responsibly manage end-of-life hardware, maximize their value recovery, and maintain incredibly strict regulatory compliance. Which brings us to our final pillar, Section 6, Return on Sustainable IT. The crucial point here is, how do we prove to stakeholders that doing good for the planet also directly benefits the corporate bottom line? Enter ROSI, or the Return on Sustainable IT. This metric is a real game changer. When you add up your operational expenditure savings, your capital expenditure recovery from refurbished assets, and the financial value of your regulatory compliance, and then divide all of that by your sustainable IT investment, well, you get a very clear picture. This equation mathematically demonstrates that transitioning to energy-efficient circular IT models generates measurable, highly competitive financial returns right alongside environmental stewardship. But as we build this future, we also have to look beyond just carbon and hardware. True ESG governance must safeguard the social fabric as well. For example, advocacy groups like the Young People's Alliance emphasize that as we deploy highly advanced emerging tools like AI companions, tech companies need to be held accountable for the psychological and social impacts these products have, particularly on youth. It really highlights that the S and the G in ESG, social and governance, are just as critical as the environmental metrics when we talk about responsible technology. So, what does this all mean for us? The convergence of digital infrastructure and ESG is a unified reality today. The data is clear, the frameworks exist, and the financial returns are measurable. The only question left is exactly what kind of future we are building. Will your organization lead the shift toward an intelligent, circular, connected ecosystem, or will you remain trapped in the toxic linear models of the past? Thank you so much for joining me on this explainer. Keep learning, keep exploring, and I'll see you next time.